let's talk about enzymes. Enzymes are substances that act on a reaction to speed it up without being part of the reaction, or they catalyze a reaction without being part of the reaction. I'll give you an example. If you're eating a burger, you put the burger in your mouth and then you expect it to digest. That process of digestion would take a very, very long time without the help of enzymes. In fact, you have some enzymes in your mouth. You have an enzyme called amylase in your mouth. The moment you put the burger into your mouth, amylase begins to work on that burger, begins to break it down. And the purpose of an enzyme is to speed up that breakdown of that burger so we can arrive at ATP. Let's take another reaction. You go to the gym and you're trying to build muscles. If you're trying to build muscles, you're trying to go from ATP to muscles without the aid of an enzyme, that process would take forever. So we have enzymes, these substances that make sure that the process of building muscle takes a little less longer than it should be. So they take part in, they speed up a reaction without being part of the reaction. Enzymes, they act on what we call substrates, and they are made up of proteins. They may facilitate breakdown or synthesis reactions. Synthesis meaning build up reactions. So let's take, for instance, you have a reactant and you have a product. You're trying to get to the product and you have these reactants. For you to go from a burger to ATP, you have to overcome certain hurdles. You have to break down the bread, you have to break down the meat, right? And so for you to do that, you need to overcome certain hurdles. The hurdle you need to overcome is what we call the activation energy. The activation energy. Without an enzyme, the activation energy is really high, and the reactant has to overcome all of this before it can become the product. The function of an enzyme is to lower the activation energy. So here is our new activation energy in the presence of an enzyme. This is our activation energy in the absence of an enzyme. By the way, this is a graph showing reaction against potential energy. This is how much potential energy is present in this equation, and it is lowered. Right here, the activation energy is lowered in the presence of an enzyme. So I like to give an example of enzymes. I like to think of basketball. Take LeBron James, right? LeBron James, the Lakers are down 1 point, right? And he's got the ball in his hand. And the burden is on him to make the shot. And he drives into the half court set, right? Gets to the top of the key. And he's ready to shoot. And around him, you've got the cheerleaders cheering him on, saying, LeBron James, you can do it. And also you've got his wife, his kids telling him, you do it, baby. We got you. And you've got Coach Vogel saying, hey, you better make that shot. Everybody around him, they're not part of the game, but they're speeding up his ability to make that shot. They're helping him along. They're cheering him on to be able to make that shot. And then he has more confidence to make that shot. So they are functioning as enzymes. They're not part of the game, but they're increasing LeBron's ability or passion or just vigor to make that shot. So those would be enzymes, things that are not part of the equation, but they speed up the equation.